This question 1647, it says determine the velocity of the rod R for any angle theta of cam C as cam rotates with a constant angular velocity. The pin connection at O does not cause an interference with the motion of plate A on C. So this is a diagram given. It shows that there's a rod R with a velocity, and this is the plate A connected with rod R, and this is a plate C which is rotating with angular velocity omega, and the cam C has a radius R, and this is a point O where there is a pin connection. And in this particular question, it does not cause any interference with the motion of plate A on C. And this is the value of X. So the value of X increases and decreases with the motion of the cam C as it rotates. So it depends on this angle theta. So when we begin our answer, first we draw the diagram and then simplify it in form of the area which we are concerned with. So as you can see, this is X, this is the rod R with any velocity, this is plate A, and this is the area of plate C we're concerned with. So from the diagram we can see that this is angle theta and this is radius R. So any point on the boundary of a circle has a distance from the center R, and the distance of the center to the plate A where it is touches the cam C is also R. So that remains constant, but this distance, this horizontal distance changes with the angle. So we have to find the velocity v of rod R for any theta. So as you can see that the velocity of the rod R depends on the motion of cam C, because as you can see over plate A is connected to rod R, and then over here when it rotates the cam C, it touches the plate A. So X is equal to R plus this distance, which is parallel to distance over here. So it is R cos theta. This is the hypotenuse, which is R. This is angle theta, and you can see that this forms a right triangle. So we can use the trigonometric ratios over here. So X become R plus R cos theta, and as you know that velocity is equal to the differentiation of X. X is the distance between 2 points. So when we differentiate both sides, dx over dt becomes v, and on the other side R is some constant, so it will become 0, and this R is constant with cos theta, so it will come on the outer side, and cos theta, as you know, is equal to minus sine theta. It becomes minus sine theta. But over here you can see that we are differentiating in form with respect to t, but in cos theta you can see there is no t. so we have to use the chain rule. So in chain rule, we do d over d theta cos theta, and chain rule d theta over dt. So as you know, d theta over dt is equal to omega, which is the angular velocity. So all of them are multiplying with each other. So as we simplify our solution, it becomes v is equal to minus r omega sine theta. So this is the velocity that we were finding of rod r for any theta. So as the angle changes, the velocity will also change in rod r. So for example, if this angle is 0, this distance is 0, the velocity becomes 0, and if this angle becomes 90 degrees, this sine theta will become is equal to 1. So this value depends on the angle, as r and omega are constant, because angular velocity in the question said that it was constant, r is also constant, and sine theta will depend on the angle, and there is a minus sign with it because as you can see that the angular velocity is in the clockwise direction.